Good morning, Zero Bell. This is Mrs. Green. If you have not previously checked your examples from the introduction to 3.5 notes that we started in class on Friday, the answer key is posted in Canvas in this module. So make sure that you do that first because you're going to need that same point slope formula for what we're going to do today. Okay? So the notes 3.5 are our last set of notes for Unit 3, and this is about parallel and perpendicular lines on the coordinate plane. So we're just going to dive right into our notes, and I'll do them along with you. So if you want to fill in as we go or take notes on a separate sheet of paper if you don't have this printed out or if you don't want to do it on Kami. All right, on parallel and perpendicular lines, parallel lines will always have the same slope, always. Perpendicular lines have blank and blank, it says. So perpendicular lines, when it says sign change, they will have opposite. So if one slope's positive to be reciprocal, the other one would have to be negative. That's what that means. And we say flip it. A lot of students say that, but it's reciprocal. So perpendicular lines have to have opposite reciprocal slopes of each other in order to be perpendicular. If two lines are perpendicular, there's our symbol, then the product of their slope will always be -1. So if you have a slope of 2, an opposite of that would be negative, but the opposite reciprocal would be -1/2. So 2 times -1/2 would be -1, and that's a quick way to check it, okay? All right, we're going to state the opposite reciprocal. If you want to do these first and then pause the video and check with mine or do them with me so you think you're fine, but the opposite reciprocal of +1/4 would be -4/1, which is just -4. If it confuses you where you don't have a fraction, remember -6 divided by 1 is the same as -6. So the opposite reciprocal would be 1/6. For number 3, -2/3, the opposite reciprocal would be +3/2. And for 9 or 9/1, the reciprocal of 9 is 1/9, but since it's positive, we need the opposite, so we would have a -1/9. And really, that's all that there is to it, okay? All right, let's go down and complete the table below. So if you're, there's 3 columns, the original slope, and then we're going to write down what would a line have that's going to be parallel to that, and then what would a line have be perpendicular. So remember, parallel slope, we want to be the same. And for perpendicular, we want opposite reciprocal. Okay? So if we have m equals a/b, then our slope that would be parallel to it would also be a/b, but perpendicular, we would need the opposite reciprocal, so that would be -b/a. For m equals -2, parallel line would also have a slope of -2. Perpendicular would be positive 1/2. For m equals 2/3, parallel slope would be also 2/3, but perpendicular would be -3/2. Now this last one you have to think about, we have m equals 0. So remember that slope would be a horizontal line. So parallel to a horizontal line is another horizontal line. So we would want slope of 0. But perpendicular to a horizontal line would be a vertical line. So this is horizontal. And we all know from our previous review in Nearpod that the slope of a vertical line would be undefined. Okay? All right, let's go on. So now we're going to really apply this very similar to what we did we're going to get to the point where we need to write equations of lines that are parallel and perpendicular to each other. So in example 5, it says if line AB has 2 coordinates and line CD has 2 coordinates, meaning it goes through at least 2 points, it wants us to know and determine, are those lines parallel? So in order to figure out if they're parallel, we have to first find the slope. So I'm going to just kind of label, I think you should too to organize your work. So we have AB, so I'm going to find that slope. Oops. This moves on me all the time with my hand. So we have M equals, this is why it was so important that you know how to do slope, 5 minus 1 all over 3 minus 1. That gives us 4 over 2, so that has a slope of 2. And then if I take a look at line CD, we would have, let's see, the y values on top all over the x values, and 2 over 1 is 2. So are the two lines parallel? Yes, because the lines have the same slope. And our work backs that up, okay? All right, example 6. It's kind of like 3 separate questions here. So the first bullet, we have 2 equations of 2 lines, and are they parallel, perpendicular, or neither? So I think what would help is to write down the slope under each one. So here we have a slope of 2. It's already in slope-intercept form. Here we have a slope of 2. So these lines are parallel. Easy enough, okay? The next one, we have a slope of positive 1/2. Here we have a slope of negative 2. Well, we know they're not parallel because those slopes are not the same, but the slopes are opposite reciprocals, so those lines are perpendicular. Okay? And finally, these last 2 equations, they are not in slope-intercept form. So we just can't look at them and identify the slope like the first 2 bullets. So I'm going to put them in slope-intercept form so that I can identify the slope. So when y equals 8 minus 3x, our slope would be negative 3. And in this one, let's see, we need to add 6x. We're trying to get y by itself. So 2y equals 16 plus 6x. And I divide everything by 2. So y equals 8 plus 3x. And here we have a slope of 3. Do not be fooled by this. Negative 3 and 3 are opposites, but they are not opposite reciprocals, and they're definitely not the same, so this would be neither. Okay? All right. The last couple examples now are really what you're going to be working with the next couple of days as you're remote learning on writing the equations. So now we know what we're looking for. We're going to write the equations of the lines. So it says, write an equation of a line that passes through this point and is parallel. Well, the first thing we need to do is say, okay, what slope do we need for our new line? So we know that the slope of this line is 3. So in our new one, our new equation, since it's parallel, it's going to need the same slope. And then we need it to go through the point 1, 5. So we're going to use that y minus the y coordinate equals the slope times x minus the x coordinate of a point on the line, just like we used in the intro notes. So I'm going to do y minus 5 equals the slope times x minus 1. Now remember, your goal is to get y by itself, but we're going to distribute. And then I can add 5. Y equals 3x plus 2. And to check it, when I plug in 1 from this point right here, it should pop out 5. Well, 3 times 1 is 3 plus 2 is 5, and it checks. Okay? All right, now we are going to we want our new line to go through 1, 5 again, but this time it's perpendicular. So we know that this has a slope of 3. That did not change. But for our new equation, we need a slope that is the opposite reciprocal of 3, which is negative 1/3. And once again, it's going through that 1, 5. So once again, I'm going to use the point slope formula. Sorry, everyone. It's going to be y minus the y coordinate equals the slope times x minus the x coordinate. So now we're going to distribute negative 1/3 times x, and then negative 1/3 times the negative 1 is positive 1/3. We add 5, that makes for easy addition with fractions. So we have y equals negative 1/3 x plus 5 and 1/3. If I plug in 1, negative 1/3 plus 5 1/3 is 5, and it checks. Okay? All right, I highly suggest that you try the next two on your own like I would have you do in class, and then come back and check them. So just pause, come back and check, and then you're good to go to move on to the assignment after this, okay? All right. So for number 7, we are writing that something that is parallel to this line right here. So the first thing we're going to have to do is we're going to have to find the slope of this line. So once again, I'm putting this in slope-intercept form by getting y by itself. So I think I've done enough with that. So hopefully you're like, oh, now I know why she had us do some of this. So this is just this same equation, but written with y by itself. So we need to identify the slope of this, which is 2. So therefore, since we want parallel, in our new equation that is parallel to this 2x minus y equals 6, we want a slope of 2, and it wants to go through the point negative 6, negative 9. So here we go again into point slope. Hopefully you have this memorized by now. The only thing I'm going to say on this one is be real careful with your signs. I tend to rewrite it instead of x minus a negative 6, it's the same thing as x plus 6. And then I don't have to worry about messing up when I distribute. So when you distribute on this right side, we get 2x plus 12. Now we can solve for y. Y equals 2x plus 3. I'm going to plug in negative 6. 2 times negative 6 is negative 12, plus 3 is negative 9, and it checks. Okay? Last but not least, we want to write the equation of a line. Ignore standard form. Sorry. That should say y-intercept form. So we're going to do y equals mx plus b form, just like we've been doing on all the other ones. Okay, so perpendicular to this. So once again, I'm going to have to figure out the slope of this line by getting y by itself. So we have 4y equals 12 minus 3x, divide everything by 4, those are 4s. And we have y equals 3 minus 3/4 x. So if we look at the slope being multiplied by x, our slope here is negative 3/4. So what that means is, since we're talking about perpendicular, we want a slope of opposite reciprocal of negative 3/4, which is positive 4/3, and it needs to go through 7, 1. So y minus the y coordinate equals the slope times x minus the x coordinate. So let's see, 4/3 times x is 4/3 x. 4/3 times negative 7 would be minus 28/3. So I'm going to add 1 to that. Use your calculator if you need to make sure that you are taking negative 28/3 plus 1. Now, if you write it as an improper fraction, that's fine. Or if you write your final answer as y equals 4/3 x minus 8 1/3, these are the same. And that is it. All right, good job. You can move on.